Well, hello and welcome YouTube. Mr. Robinson back here yet again. And you know what? Actually, literally, again, I won't lie. I already made this video. The file corrupted for my video, or it stopped short, something about encoding. I'm going to keep monitoring it. Hope it doesn't happen again. Obviously, this video is either up or not, but a little bit of a level of frustration on my end having to redo something that you've already done, and whatever. So I really hope I can do this with, not going too fast on things. With this. So anyway, so what you're looking at right here is integrated math 3. I did an overview of 50 such questions of a review with this stuff, and now this is more of a test-like environment with this stuff, pre-test for my kiddos as they are going to do an official test, down the line. So let me just look through these problems and point out some of the things that I saw from my own students as errors or, whatever, little things like that. First three are find each product, and that just means multiply whatever's factored out into standard form. You're not solving anything. And literally standard form in descending order of degree, or always assume that at least, right? So we got to multiply 8a squared with these three terms, like boom, boom, boom. We got to multiply negative 4a with these three terms, boom, boom, boom. And negative 8 with these three terms right here, boom, boom, boom. Now, being multiple choice, you can work until you feel like you have the right answer, but of course I'd like to do the work if in the event you don't have multiple choice, or to show how you can narrow things down until you know what the answer is going to be. So we start with 8a squared times 2a squared, and there we get 16a to the fourth power. So you can already see that there's nothing else that's going to be the fourth power. 64a to the fourth power is kind of out in that regard. You're down to a and c already. And you can already see where a comes from. It's multiplying these two and then these two and these two. And that's not proper distribution. It's already not going to be a. It is going to be c. Let's see how we get the rest here. 8a squared times negative a squared and 8a squared times 3. So we get those three terms right there. And then we go negative 4a times 2a squared, negative 8a cubed, negative 4a times negative a, and then negative 4a times 3 right there. And then negative 8 times 2a squared, negative 8 times negative a, and negative 8 times 3. So again, you combine like terms. We're going to get to that right there. It's not really worth me writing the rest. I'll call them out loud though. Negative 8a cubed minus 8a cubed is negative 16a cubed. 24a squared plus 4a squared minus 16a squared is 12a squared. Negative 12a plus 8a is negative 4a, and then negative 24 is there. And so you get c. Okay, number 2. This is a difference of two squares, and you could foil the thing out, but the middle terms will cancel. It's kind of worth showing that it is just this squared. Whoops, not that. It is 8x quantity squared minus 4 squared, which 8 squared is 64, and then 4 squared is 16, like that. And again, it's important to practice that. Not only is it efficient, but then you start to recognize difference of two squares in their appearance and what it means to factor them, right? Going from here to here. And that's something that just shows up. We're going to have, I think, a couple of those situations here on this pretest. I should know because I literally just came from doing it before. And then this is a perfect square trinomial. You don't just square the two terms, right? You multiply into them, which means there are two middle terms that combine. It's the same thing twice, which means you double up. So remember, you square the first term here. You do square the last term, but you double and subtract, because subtraction. You double the product of these two guys right there. And then that's 36x squared. Doubling 18 is 36, so minus 36x and plus 9. And remember, you're not solving anything. You don't want to factor this down afterward. Remember, this is factored down right here, not as best as possible. I guess they're GCFs. But you're expanding. You're finding the product. It's called simplifying also, going this way. And you're not solving anything. These aren't set equal to 0. And I'm saying these things because these are the little things my students would do. And look, you're taking a test. You practice some things, and you feel you need to conquer more than is possible, and that's not really what you're supposed to do here. Follow the instruction, go from there. Like expand completely, and again, it's multiple choice, and I think after you find out the first term here, you'll kind of know what the answer is, but we'll carry through anyway. This is best used with Pascal's triangle here. If I build that, add some ones down here, and then add whatever's in between. 1 plus 2 is 3, etc. This is row 0, 1, 2, and 3. And I want row 3 here for raising to the third power. In your 4 terms, these are your 4 coefficients that appear, or at least that multiply. I shouldn't say that appear, because otherwise you'll think this is the answer here. But the 4 numbers that multiply by the values that you get when you raise this to a power and this to a power that add to degree 3. So the idea here is you're going to take 1 and multiply by 4x to the 4th cubed times negative 1 to the 0. So it's just 4x to the 4th cubed. Then you're going to add 3 by 4x to the 4th squared, and then the negative 1 will be to the first power. And then you're going to add 3 by 4x to the 4th to the first power, and negative 1 gets squared. And then 1 times 4x to the 4th to the 0, and negative 1 to the 3rd. That's kind of the cleaner way I'll write that. 4 cubed is 64, and you can see where it's already going to be c based on that. It's not going to be the other ones. Oh, x to the 4th is being cubed, I'm sorry. And all these will kind of show the same exponents. X to the 12th, x to the 8th, x to the 4th, and constant. X to the 4th cubed is x to the 12th, 4 times 3 happens there. 4 gets squared, which is 16, times 3 is 48, times negative 1 is negative 48, so actually that's a minus. Minus 48 right there. And this is x to the 8th power. And then 3 times 4 is 12, and we get negative 1 squared is positive 1, x to the 4th, and then negative 1 cubed is negative 1. So we do get that answer C. It looks like it does line up, and you're all good to go. All right, number 5. This is a division problem, and I recommend long division, although we will check out the synthetic division version and what would happen and, what you need to take into account when that does happen here. So in long division, the first thing, I think even in long division, it's going to be super important here, but especially in synthetic division. Long division, get this in standard form. These need to be in descending, let me mute this thing right here. These need to be in descending order of degree. So negative 28r to the 5th is the first term that you want to, divide by when you're doing this here. And then we have 13r to the 4th, 2r cubed, and 3r squared. And this all divides by 4r minus 3. And again, you're trying to find the quotient of this, right? You're trying to divide it and find the quotient. I don't want factored form of this polynomial or anything else. I just want what is the result of dividing this. Like 72 divided by 9, what is it? It's 8, right? I don't want to factor 72 into 36 and 2 and things like that. 4r goes into negative 28r to the 5th, negative 7r to the 4th times. When you multiply those two, you get negative 28r to the 5th. Those will subtract and cancel. Negative 3 times negative 7r to the 4th is 21r to the 4th. Subtract those ones, and you get negative 8r to the 4th. And then 4r goes into negative 8r to the 4th, negative 2r cubed times. You multiply those two, you get that negative 8r to the 4th. Negative 3 times negative 2r cubed is positive 6r cubed. Subtract those, you get negative 4r cubed. And then 4r goes into negative 4r cubed, negative 1r squared times. Multiply those guys right there. Negative 3 times negative r squared is positive 3r squared. Subtract those, you get your 0 remainder. So your quotient is this guy right here, and that's really all that's being sought out right there. No, don't factor further. Divide. That's the instruction, divide. In a homework, in a video that I showed in an assignment, it was divide and then rewrite the polynomial as a factored form of something, which will be important for what we do in numbers 6, 7, 8, 9, I think 10 and 11. Numbers 10 and 11, you got to do that in some other ones where you factor completely through synthetic division once you find a root and factor, right? This one, just divide. Now, before I do these problems here, let's try the synthetic division version of this, which, like I said, does require standard form. So, especially in synthetic division, I assume long division would as well. But negative 28, for example, would be my leading coefficient there, and then the 13, and then the 2, and then the 3. And that's just down to r squared, and you could stop there as long as you understand that when you see your results right here that this is not the remainder, which will be important, right? This isn't the remainder. If this is the quadratic term here, the quadratic term, then this is your constant term. I guess everything else will be zeros, but you got to know that this is still a quartic and cubic and quadratic right there, right? Some things are going to pan out. So you still want a 0 and a 0. This is negative 28r to the 5th, plus 13r to the 4th, plus 2r cubed, plus 3r squared, plus 0r plus 0. You want to go all the way down. Now your root. Your root is not 3 in this case. It's not just opposite of this number. No, it's when does the factor, right? The root is, when does that equal 0? Sorry about that. Add 3 divided by 4, you get 3/4. And 3/4 is that root that we placed there. So that means when we are doing synthetic division here, we're not dividing by 4r minus 3 anymore. Now we are dividing by r minus 3/4. And then we got to divide it by 4 afterward. This whole thing is what's dividing, but we're going to start with this part. So the 4 has to divide afterward. That's what makes synthetic division a little weirder here. Plus the 3/4. Negative 28 times 3/4 is negative 21. And that adds to negative 8 times 3/4 is negative 6. I'm not going to spend time, synthetic division. Negative 3, and you get 0 times 0, 0 plus 0, 0 times 0, 0 plus 0, 0. So this is the remainder down here. No constant term, no linear term. This is a quadratic, cubic, and quartic. And remember, these all have to divide by 4 now as well. So because we only divided by r minus 3/4, we did not divide the 4. I'm trying to move everything up. I'm sorry. It seems to not want to drag them all. Okay, that's annoying. So anyway, divide those by 4. Negative 28 divided by 4 is negative 7. So that's negative 7 r to the 4th. Negative 8 divided by 4 is negative 2. That's negative 2r cubed. And negative 4 divided by 4 is negative 1. So that's the r squared term. And those are the values. So, I'm not saying I don't recommend synthetic, but you got to know what's going on in synthetic to decide whether it's appropriate for you. I personally do long division. It probably is longer to do in that regard, but I feel safer with it. I kind of feel like I know what I'm doing, especially with the remainder, if there's a remainder. Because the remainder wouldn't divide by 4 there. Excuse me. Okay, factor each completely. I have to pause. Give me 1 second. Okay, just had to do a quick throat clear. All right. Factor each completely. Now, factor, don't solve and factor completely down, right? I'm not solving for x equals, because here's the thing. People go like, oh, x equals 7, x equals negative 2. I'm sorry, this is not set equal to 0 right here. That's when you're using zero product property and factoring and saying something equals 0. This isn't equal to 0, and they're not asking us to find the zeros, meaning set this equal to 0. So we're just factoring this thing down. Pretend like it's just an expression. X, you're not solving for x in any sort of thing. And who knows, maybe x equals 10 right here. You don't know what it's set equal to. It's not comparing. So anyway, factoring completely also means GCFs. There's a GCF of 3 here. So if you factor a 3 out, we're left with 2x squared plus 13x plus 15. This is where you get to play a little bit, and you get to ask yourself here, is there anything that you can, some 2x times x with a couple pluses here? I would want to probably try 5 and 3. You could try like 5 and 3 right there. 6 plus 5, no. And you could, oh goodness. You could try 5 and 3 here. 10 plus 3, that works. I could try 15, but once you multiply by 15, you're going above 13. So I'm done there. And again, it's not x equals negative. Listen, x doesn't equal negative 5. X doesn't equal negative 2/3 or 3/2. You don't know what f of x equals. We're not finding zeros. This is just f of x equals. We factored. We're all taken care of. That's it. And the GCF. You have to take out the GCF. A lot of people are leaving it in, writing 6x plus 9 as this factor, something like that, and you're ignoring the fact that there was a GCF. You should have probably taken care of first. With this one as well, there's a greatest common factor of an x squared right there, and then you're left with 5x cubed, 15x to the squared minus x plus 3. And yeah, you can still factor by grouping right here. You always kind of seek that out. Notice how this is 3 times larger than that number, 3 times larger than that number. Sign changes, all that jazz. So let's keep going. Take out 5x squared from here. You have x minus 3. Take out negative 1 here. You get x minus 3. And listen, I apologize if I'm speaking quickly. This is for 2 reasons. 1, I already made this video. 2, I probably spoke a little quickly in the last one. This is y'all took this. Now I'm just giving you the solutions and saying where I saw mistakes. So, for instance, I didn't really explain factoring by grouping here, right? X minus 3 is a common factor that exists in both of these guys right here. X squared is nested outside of the grouping, where I'm factoring by grouping, but it's still a product. And 5x squared minus 1 remains in the other set there. So that's the factor by grouping bit. And listen, if this wasn't a 5, but it was a 9 or a 4, that's a difference of 2 squares, right? But 5 isn't a perfect square like 9 and 4 and 1. So you're done there. But you look for those perfect difference of 2 squares and go after them. Number 8, this is a quartic and quadratic form right here. So this factors into an x squared times x squared deal. But it's a 1x squared. You're looking for 2 numbers that multiply to 45 and add to negative 14. So it's a minus effect right there, like 9 and 5, like that. That's what we're trying to do. Now this is a difference of 2 squares right here. This is 1x squared minus 9. That factors into x minus 3 times x plus 3. And only until you factor that down, this is not a difference of 2 squares. 5 is not a perfect square. Only until you factor that thing down like that have you factored completely. All right. Another GCF right here on this guy. There's an x that we can factor out. And you're left with 125x cubed plus 64. This should really call attention to you right here. I think for most people it does when the numbers are like that. You've seen them several times. It is a sum of 2 cubes. But this factors down to a cubed plus b cubed. Here's what it's not. It is not right? It's not 5x plus 4 cubed, right? You don't factor out the cube. We've established this many times that that's not how that works. If it was that easy, then I would have just written that for this answer right here, right? This would have been just 64x to the 12th minus 1. And that's not the case. So let's make sure we really clearly establish what it's not. And that's one of the things. So anyway, sum of two cubes. It is, you're cubing 5x, so that's a plus, and then you're cubing 4b, a plus b. And then a squared minus ab, multiply, plus b squared. And we've mentioned before that quadratic can't factor further, right? It kind of stays like that there. So there's the first 9 problems. There are actually only 6 more problems to go, but they are possibly of the longer variety. And actually, number 10 really is. It was a longer, there really wasn't as much room here than what was needed. You need to do synthetic division twice. You need to, I think, factor a quadratic after that. Yeah, there's just a little bit to do. Rational root theorem at one point. Now, you don't need to do it at the beginning. One root's been given for number 10, while, that's my own typo, while no root has been given for number 11. So on number 10, they first give you a root of -3. Without testing p's over q's, we know that one of them is -3 already. So we are going to factor out its x plus 3 factor, right? If x equals -3, then x plus 3 is a factor. We need to factor, we're not solving. X equals -3 may be a root, but we're not solving. We are factoring. This is going to factor into x plus 3 times something. We need to figure out what that is by dividing x plus 3 out by using the -3 root in synthetic division. So let's go. Standard form, 1, 2, -8, -18, -9. And I'm not going to waste time on it. Precious time, that is. Again, kind of already done this. It's different. I teach, right? And I'll teach 3 times a day the same thing, but I don't feel bothered by it because I know I reached out to someone at the time I taught it. This first time I spent 40 whatever minutes doing this thing, it went to nobody. It didn't even go to my computer. I think 10 minutes went in, it stops and chugs, and that's it. So that's what feels like the waste, right? When you reached out to nobody. If I even reached out to one person on it, I would have felt good. Here, no, not really. Okay, so there's that start, right? Now, so far, this factors into x plus 3 times x cubed minus x squared minus 5x minus 3. That's what those guys are right there with the 0 remainder. But it just so happens that this is potentially more factorable. And you can't factor by grouping, but you can still try and find rational roots. So I'm going to try the p's over q's here. Factors of 3 divided by factors of 1. That's 1 and 3. And try some values out and see which ones work. If you try 1, that's 1 minus 1 minus 5 minus 3. No. -1. -1 minus 1 is -2. Plus 5 is 3. Minus 3 is 0. So that does work. -1. So I'm going to use -1 this time on these guys here. Remember, these are the coefficients we're dealing with. Maybe this saves me my room. Then maybe this is how you can use synthetic division. Yeah, I don't need that part. But maybe this is where I can use synthetic division a little faster, or a little smaller right there. So we will get this right here. So now we have taken this and we factored out, right, -1 was a root. That means x plus 1 is a factor. So I just factored x plus 1 out. I factored x plus 1 out. And now I have x squared minus 2x minus 3. Whoops. And I won't have to use rational root theorem here. Now that it's a quadratic, I can decide whether or not this is factorable on my own. And this factors to x minus 3 times x plus 1. So x minus 3 times x plus 1. And that can be an answer right there, right? F of x equals yada yada. We're not solving, even though your roots would be -3, -1, 3, and -1, so multiplicity of 2. So, and also you could write it by condensing those x plus 1s into a single factor, like squared, like that, and that's a fine answer as well. But you can't leave out the fact, you have to completely factor, and you can't leave out the factors from the roots that you already found, right? We found roots, we write them in their factored form. That's why we're factoring completely. We're not solving anything. We're not solving anything there. All right, number 11. Number 11 right here, 2x cubed plus x squared minus 5x plus 2. Again, no factoring by grouping. I think that was kind of the hint that you were supposed to see here, where one root's been given, no root's been given here. You got to use rational root theorem. And we're going to try our p's over q's. Factors of 2 over factors of 1. factors of 2, which are, let me write that again actually then, our p's over q's. Factors of 2 are 1 and 2, so we're going to divide 1 and 2 by 1 and 2. That sounds weird. But 1 and 2 divided by 1 is 1 and 2, plus or minus. And then 1 divided by 2 is 1/2. 2 divided by 2 is 1, so we're going to leave those out because it's already duplicate. So there's 6 possibilities. Let's start at 1, and that's 2 plus 1 minus 5 plus 2. That is 0. So 1 is your synthetic division here, and we get 2, 1, negative 5, 2. We're going to factor x minus 1 out of here and see what remains. This might be the easier problem of the two. I just figured since this was given, you have a head start in thinking about what to do. And this one has a little bit of a different kind of factor, so who knows. So this thing factors out to x minus 1, that was this guy here, x minus 1 times this guy, 2x squared plus 3x minus 2. And we got to check and see if this can factor further. And I think you can bet it can. Let's check it out. 2x and x. Now negative 2, right? The 2 can't go here without being a GCF with that, so we got to place the 2 and the 1 here. Which one's positive, which one's negative? We need a positive 3, so plus 4 minus 1. 4 minus 1. And that'll be that, and that's all it can factor down to. Again, nothing else to solve, or nothing to solve. That's it, you're done. Okay, write a polynomial function in standard form of least degree with integral coefficients that has the given zeros. For this problem only, receive that's the quiz thing. So first I'll write this out in a factored form, and then I'll expand it out in standard form. Not much to do in the standard form portion. I just wanted to not make it more complicated than maybe it would need to be. So the idea here, guys, is to be least degree, then use as few roots as possible, but only using these 2 roots would not be enough. If x equaled negative 5, and x equaled positive root 6 for some polynomial, we want to figure out what that polynomial looks like, then we know that x plus 5 is a factor, and x minus root 6 is a factor. But if I expand this out, there will be irrational coefficients. We need integral coefficients. So there needs to be its conjugate. If root 6 is a root, then negative root 6 has to be a root, which means x can equal negative root 6, which means x plus root 6 also has to be a factor. Now, you don't need a conjugate of positive root 5, and in fact, if you added x minus 5 as a thing, then you didn't make it of least degree. You just made a quartic when you could have just had a cubic. So this is a great factored form answer of that thing right there. And if you want a standard form, then you have to expand everything out right here. So standard form, or expanded. I'm going to start by expanding the x minus root 6 times x plus root 6. That's the difference of 2 squares, x squared minus root 6 squared. So that's x squared minus 6. So x squared minus 6, and multiply that by x plus 5, and now you FOIL, which is x cubed plus 5x squared minus 6x minus 30. And that's it. So that's the full credit you can get there, just expanding it out. And this is one of the easier ones. It's harder when you have like a 1 plus root 6 and 1 minus root 6, because now you're doing trinomials. And it's, I mean, you can do them, right? Clearly you did them for number 1 right here, but it's just with roots and stuff, even though they cancel. It's a little crazy party. But yeah, take the zeros, write out the factored form, and that's something, listen, when you start graphing the next unit, right? When I start doing the next videos, that's what we're going to be looking at. Doing a lot of those. All right, 13 comes in 2 parts. State the possible rational zeros, and then find all the rational zeros, right? The possible ones are what could possibly exist in the polynomial. All of them are what ones actually do. So in this one here, we got to do factors of p over q, factors of 27, excuse me, p over q, factors of 27 over factors of 2. So I'll say them out loud, see which one matches up. Factors of 27 are 1, 3, 9, and 7. Actually, let me write that. So 1, 3, 9, and 7. 27, if I said 7, I'm sorry. 1, 3, 9, and 27. And then factors of 2 are 1 and 2. So our list should be plus or minus, for all of them, plus or minus 1, 3, 9, and 27, plus or minus 1 half, 3 halves, 9 halves, 27 halves. That's not A, that's not B, it's C, and not D, right? Couldn't have ever been B, because 0 is not one of our possible rational zeros. We would do that after taking out any common factors, right? Any GCFs, and that would include an X. Having an X as a GCF would give you a 0. These would need fractions by dividing by 2. Same with this. Looks like that's the only result. And here's the thing. If this is the list of possibles here, then clearly it can't be B here, since 0 is not in this list, and neither is 1/3 here. So it's between C and D. So let's just try these two. I know that generally I would say, hey, go through all of these and find it out. Or this doesn't factor by grouping, so or find one of them, synthetically divide, and then try and factor out the quadratic, right? Or use the calculator and try all of them out. But here, because of the multiple choice idea, let's just try some, see what works. Let's see if -3 works by either synthetic division or substitute in. See if you get 0. -3 cubed is -27, times 2 is -54. -9 times 9, -3 squared, is 81. So -54 minus 81 is -135. -54 is -189. -27 is -216. So clearly not 0. So it looks like it's got to be D. Let's check and see if that'll work out the way we want it to. F of 3. So 54 minus 81 plus 54. So 108 minus 81 is 27. Minus 27 is 0. Yes. And that one does check out. Ding, ding. And it appears it's the only one. If you use synthetic division, let me show you that. If you use synthetic division, what you'll find is that you'll get a 0 remainder, right? But this other quadratic must not be factorable, basically. So let's see. Oh, hold on. I must have messed something up. Am I multiplying by 3? -9. I was multiplying. Give me 1 second. I looked at these two, I guess. -9 and 27. Okay. So 2x squared minus 3x plus 9 must not factor. You can try 2x and x, and then a minus, and then either 9 and 1 or 3 and 3. It's too, they get too big. So that doesn't work out there, right? So anyway, the others must be then probably imaginary solutions. All right, find all zeros here. Compared to the previous problems where they ask you to factor completely with f of x, this says find all zeros. This time I want you to solve. I want this to say x equals this and x equals that. Maybe we use quadratic formula or completing the square. Maybe we factor it down as they're all possibly rational zeros. But we can't factor by grouping. It is a cubic. So we do start by rational root theorem here. We'll do our factors of 1 over factors of 5, which seem to be plus or minus 1 and plus or minus 1/5. So let's hope it's 1 or -1 before I dive down the 1/5 rabbit hole. Then I'll really have to go to the calculator here. And there has to be at least one rational zero with it being an odd degree, right? At least one of them. You'll see, again, when we start graphing, you'll see why that's... Well, you see why that has to be a real zero. Rational zeros, I guess that I can't state that for sure. But, well, I can state for sure. I can't say why you know for sure. I'm done talking here. F of 1. 5 minus 11 is -6, plus 7 is 1, minus 1 is 0. So that's good. Let's divide that out. Remember, we're not dividing by 1, right? Dividing by 1 is just that. We're dividing by x minus 1, or we're factoring out the x minus 1, I should say. Because I still want that factor there. Listen, 1 is one of your roots. Find all 0 is one of your zeros. We just found a 0. Setting this equal to 0, by the way. 5, -11, 7, and -1. Here, we'll multiply these by 1. And then we get 5x squared minus 6x plus 1. So now we have x minus 1 factored out of 5x squared, of that, and we get 5x squared minus 6x plus 1 set equal to 0. We know that that would be one of our zeros there, but let's see if this can keep factoring. 5x and x, and there's only one thing we're really testing. Minus, 1 and 1. Does it work? -5 minus 1 is -6. It does work. Now notice there are two x minus 1s there, so if you're trying to answer it, it's like, oh, either x equals 1 or x equals 1. That's what we call a multiplicity of 2. If you didn't exactly put that, or if you put 2x equals 1s, I'm fine either way, but we're going to look at multiplicities down the line. And then 5x minus 1 equals 0, x equals 1/5. You add 1, divide by 5 from both sides there. And that would be the end of the main stuff there. Now we're at the bonus question here, and I'm on good time. Still have, well, beating my last time, and that might be a bad thing because I'm probably talking fast. Find the other 3 roots after 1's been given. None of them are rational. Don't even bother with rational root theorem. I already told you none of them are rational right here. So 2i is one of them. Now what we've also been bringing up right here is, the idea of, listen, you could use synthetic division with 2i, and I'm going to show you the synthetic division form of this last. But I'd rather use long division, and the reason is because, this is like dividing by x minus 2i, da-da-da-da-da. So we're dividing by one of the factors here, but 2i wouldn't be the only root that exists if there are rational coefficients and a constant. In the polynomial, that means negative 2i is also one of your roots. So I found one of my three roots, negative 2i. So plus or minus 2i are two of them. And there are two others that we'll find. So we'll divide with these, but let's divide by them together. Let's not just divide by x minus 2i, whatever. Let's divide by x plus 2i. And if you multiply these out, that's x squared minus 4i squared, or x squared plus 4 squared. So let's divide by x squared, x squared plus 4. X squared plus 4. And that is long division because it's a quadratic. So I'm going to use long division here and divide by both of these at the same time. And remember, in dividing, I am trying to find my other roots. Whether you call it factoring or otherwise, we need to see what this shrinks down to. X squared goes into the fourth, x squared times. Multiply those and line them up with matching degrees there. Subtract those, you get negative 49x squared. Bring the rest down. X squared goes into negative 2x cubed, negative 2x times. Multiply those, you get negative 2x cubed. Multiply those, you get 8x, and that's a plus 4, so that should be a minus 8x there. Subtract that result there, that's 0 as well, and negative 49x squared minus 196. X squared goes into negative 49x squared, negative 49 times. And that is negative 49x squared, and 4 times negative 49 is indeed negative 196, and you get the 0 remainder. As you should, right? You were told what one of the roots were. The conjugate has to be a root in this regard as well. So that becomes x squared minus 2x minus 49. So we need to find out what these other two roots are here, setting that equal to 0, or the other, zeros. Setting that part equal to 0. We could use quadratic formula. You know me, I prefer completing the square in this situation here. Add the 49 over. Add the same thing to both sides right here. Divide this by 2 is negative 1. Square that is 1. That equals 50. This factors down to x minus 1 squared, and we can take the square root of both sides. Yes, I am rushing. Are you rushing or are you dragging? Were you rushing or were you dragging? Extra credit to a student who can answer that in class the next day, assuming they watch this. Are you a rusher or are you a dragger? Plus or minus root 25 times root 2 is 5 root 2. God, it's such a good movie. Add 1 and you get 1 plus or minus 5 root 2. So those are the other two answers there. So we have plus or minus 2i and plus or minus 1 plus or minus 5 root 2. Those are our 4, right? We had this one already. So yeah, that's what you do. You establish that negative 2i is another root there, and you divide them out. You can divide them out together in long division. You could divide them out separately. I wouldn't use long for that. I'd use synthetic, but divide by 2i and then, x minus 2i and then divide by x plus 2i. So I'll show you the synthetic version and you'll see why, maybe long is your forte, even though you're like, And then anyway, find the rest. They weren't rational, so you had to use quadratic formula or completing the square. I did completing the square. Let's go ahead and look at the same thing here. Only let's use synthetic division on it. And when I do, I got to use, 1, negative 2, negative 45, negative 8, 1, negative 1, negative 6. Okay, with those 5 right there, we're going to divide it by x minus 2y with 2y as the root. And then we'll divide it by x plus 2y with negative 2y as the root. Remember, synthetic division requires a 1x linear coefficient, so you got to do one root at a time. So if 2i is your root to start off with here, that's 1, 2i. These do not combine. That's negative 2 plus 2i. Multiply both of these by 2i. That's negative 4i plus 4i squared, which is minus 4. Combine those through addition, right? This is negative 4i minus 49. Multiply those by 2i. That's negative 8i squared, which is positive 8, I think. And then negative 49 times 2i is negative 98i. Add those. Those are gone. Let's see. Yeah, those are gone with each other. You get negative 98i. Times 2i is negative 196i squared, which is positive 196. Add those, you get 0. And we have that right there. Now, this part doesn't matter here, but what this is here is this is now x cubed. And then plus, that's negative 2 plus 2i times x squared. And then plus negative 4i minus 49x. Generally, you'd write the real term first, but that doesn't matter. minus 98i, and that's your imaginary constant. But as you noticed, right, our polynomial didn't have irrational, or excuse me, imaginary coefficients and stuff like that. This looks a little weird because we're missing dividing its conjugate still. We have to get its negative 2i out of here as well. So let's do that with what remains there. Let's get negative 2i divided out of this guy, and let's see how we finish that off. Bring down, remember, it's just these ones here. Bring down the 1, negative 2i times that is negative 2i. Those add and go away. You're left with negative 2 times negative 2i is positive 4i. Those go away. You add those negative 49 times negative 2i is positive 98i. And then add those, and those go away, and you get 0. And there's your x squared minus 2x minus 49. Set it equal to 0. You know, I didn't do quadratic formula last time. Let's just do it right now and then cap this thing off. I'll write out the thing. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So positive 2 plus or minus the square root of 4 plus 98 times 2 is 196 over 2. And that's 2 plus or minus root 200. Oh, I didn't even write 2. 2 plus or minus root 200 divided by 2. Root 200 is root 100 times root 2, so 10 root 2. I did it again. What's going on? 2 plus or minus 10 root 2. I really want to finish. Over 2. Divide those both by 2. You get 1 plus or minus 5 root 2. So those were those other two answers. Again, 2i, negative 2i, 1 plus 5 root 2, 1 minus 5 root 2. Those are your 4. And that's your bonus there. All right, guys, that ought to do it for this one here. And, you know, hopefully everything I explained made some sense as I gave my kiddos, not a realistic hour, but about 50 minutes, 55 minutes, whatever it was, to do their pretest there. I hope that me finishing in that time wasn't over long, even through explanations or alternate versions and things like that. And you can see through some mistakes or some things that were actually expected and what you can do carrying forward. It can feel like a lot, but the idea was a lot of this came through IM2. If you learned that stuff before in factoring and quadratic formula and completing the square and yada yada, there's some new things, expansion, sum of two cubes, things in quartic form, but it's still like factoring. And then the rational root theorem. I was an IM2 even as well, the imaginary. All right, guys, so that ought to do it for this one. This is Mr. Robinson. Thank you so much for watching. Take care, and I hope this thing gets uploaded correctly. I'll see you in the next one.